Okay, so now let's solve some equations where they, give us numbers to plug in and see how it goes, where we have to solve for the variable, where the variable is not already isolated. Okay, so on this one, calculate the constant for an calculate the constant, okay? And so that would be E. E is the constant. So we want to solve E, and E is not already isolated. All right, so the absorbance is 12 and a half. So I replace the A with 12 and a half. Okay. And then, let's see, the concentration is C. I'm going to replace that with 3.2. And then the path length is 7.8. So that goes there. All right. So let's see how we do this. First off, why don't we just multiply those two together just to kind of tidy up that right side, since that is something we can do. Let's see. So I'll go 3.2 times 7.8. And we get 24.96. I'll just stay on this screen. Okay, now, when you are solving for a variable, okay, you need to get it by itself. You do the opposite of what's being done to it. Okay, what's being done to the E? It's being multiplied by 24.96. Well, what's the opposite of multiplying by 24.96? Dividing by 24.96 is the opposite. All right. So we do that because 24.96 divided by 24.96 is 0, or is 1, as in one single E. So now we can take, let's see, 12.5 divided by this guy, and we get this number. Let's see, and it says, let's do this to one decimal place. One decimal place is 1/2, and it doesn't really say what the units are. Okay, so I'll just say 1/2, and that'll get the job done. Okay, now there is an alternative method for doing this problem, and the method I used and the alternative, they both work every time. Okay. The alternative method, and I don't care which way you do it, is, hey, let's solve for, let's solve for E right off the bat. Well, what's being done to E? It's being multiplied by CL. So let's divide by CL. Okay, C's cancel, L's cancel, and I get E equals A over CL. And then I can say, well, I know A is 12 and a half. I know that C is 3.2. And I know that L is 7.8. And then I just go straight to the calculator at this point, plug that in, and I'm done. And I get 1/2 once again. And you'll notice this right here, that's the same thing that we had before. Okay, keep an eye on that. And then if I go back to here, oh, it's not bringing it up. Well, that's unfortunate. Okay, but yeah, it's the exact same thing. Okay, the 12 and a half is, remember how we did 12 and a half divided by 24.96? Well, we were dividing by 3.2 times 7.8. So it's the same thing. I tend to just plug the numbers in and go. Some people prefer to get the variable by itself first. Okay, so that's, but I'm going to do the first way. Now let's try number 5. The weight of a metal water tank is modeled by this formula here. Okay, so there's the total weight, and G is the number of gallons of water in the tank. the amount of water. And this makes sense, okay? And if you think about the formula, it's like, oh, okay, well, you've got the tank itself when it's empty is 3250. But then you're going to add to that 8.345 pounds for every gallon of water. Okay, but if it's empty, yeah, 3250. All right, so find the number of gallons that can be hoisted by a crane capable of lifting 30 tons, rounded to the nearest whole number. Now, they give us 30 tons. So the whole thing is 30 tons, the complete weight. But notice that W is being measured in pounds, not tons. Therefore, I must use the 60,000. So I'll plug 60,000 in for W. Okay, and now it's time to solve for G. So what's being done to the variable? Well, it's being multiplied by 8.345 and it's being added by 3250. Okay, deal with the stuff that's added and subtracted first. Okay, so I'll subtract 3250 from both sides. And that'll give me 56,750 pounds. Whoops, I forgot my 7. Okay, I apologize that it's a little hard to read. Okay, and now I'm going to take care of 8.345. It's being multiplied by G. So to undo that, do the opposite. Divide it by G. Divide by 8.345. And if I do it to one side, I got to do it, oops, to both. So those cancel. And after dividing, I find that G is, let's see, how do we round this thing off? Nearest whole number. Okay, so it rounds off to 6,800 gallons. And that would be the end of that one. So, so remember, we saw before that the order of operations was this. And we said, yeah, this is the order we do things, but in a formula where you've already got things being done to your variable, you're not, those things are already done. The order of operations has already been executed on the variable. So we want to peel away those layers that have already been done. And so we have to go in the opposite direction. So that's why we start with things that are added or subtracted to the variable. Then we tackle the things that are multiplied or divided, except in certain circumstances. And we'll see those here in just a few moments. All right, let's look at another one. Okay, so here we have the thickness of the wall of the pipe can be found using this formula. So how thick is that? How long is that distance there? Okay, I guess I can just read that. And they say, well, T, the outside diameter, or I'm sorry, find the outside diameter if T is 1.32. So we will replace T with 1.32. And we're looking for the outside diameter, and the inside diameter is 14. Okay. Now, this problem is just a little bit different, just a little, from the other ones. This one has a denominator. So, rule number 1 in life, when you've got a denominator, get rid of it. So I'm going to multiply both sides by the denominator. Whether the denominator is 2, -8, x plus y, multiply away that denominator. Okay, at least if you want your life to be just a little easier. I like easy. Okay, now the problem is considerably easier. It's just, oh, okay, what's being done to the variable? Well, we're subtracting 14 from it. Okay, so the opposite of that, the inverse, would be adding 14. And so I do it to both sides. and the outside diameter is 16.64 millimeters. And the problem is done. So, but the main thing on this one was when you've got that denominator, multiply both sides by it so that it goes away. All right, that is the main thing I want you to get from this particular problem. All righty, let's look at number 11. We got torque and horsepower and RPMs. All right, so find the horsepower, find the H. That's what we're solving for. If the torque, if we got 680 foot-pounds of torque, because the units are foot-pounds, that means that you got to multiply feet by pounds in order to get your torque. All right. And then we got the H, and then the RPMs was 2560. So I plug everything in right where it goes. And I say, whoa, 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 I got a denominator. Okay, I'm dividing by something. I got to get rid of that. So let's multiply that away. So I'm running out of room on the left. So I'm just going to say, there, I multiplied both sides by it. Okay. And so on the left side of the equation, I get 680 multiplied by 2560, which is 1740800. That's a zero. Okay. So 1,740,800. Okay. And on the right side, they cancel, and I get 52H. All right. And then at this point, I would divide both sides by 52, the opposite of being multiplied, opposite of what's going on there. Okay, so those guys cancel, and I am left with, let's see, it says nearest whole number, so that would be 331 horsepower measured in, is it horsepower? That's the unit, isn't it? Yeah. 331 horsepower. And that'd be how you do it. Now, there is a slight shortcut that is totally unnecessary, but I would be remiss if I did not show it to you. Okay. What if I did this? What if I said, hey, let's just multiply both sides by 2560 over 5252. Oh, okay. So that on the right side, those cancel and those cancel. Okay. And on the left side, I don't want to go to my calculator. On the left side, I end up with my 680 multiplied by 2560 over 5252, and let's turn that into a decimal, and I still get the 331. Okay, and so it's just doing it in one step instead of two. It's, if you like it, great. If you don't, that's fine. It doesn't matter. I just needed to show that to you, but I was able to do it because there's no adding or subtracting going on in there. It's just multiplying and dividing. And therefore I've got those, I've got this extra option available to me. Okay, so let's do that same problem again, but this time different numbers. This time we're solving for a different variable. Okay, whoops, got it. All right. So it says that we've got 870 foot-pounds of torque. All right, so 870 takes the place of T, and then we've got the 52, and this time they tell us, hey, the horsepower is 1200 horsepower. And what we're looking for is the RPMs, which is in the denominator. Holy smokes, how do we handle that? Well, we've got a denominator. Get rid of the denominator by multiplying both sides by it. That is going to be our strategy. just like it was, before from the last problem. So we got that, and now we can say, all right, well, I've got R times 870 equals, and it's 52 times 1200, but I might as well just multiply that out and get 630, 24, and a couple of zeros. So 6,302,400. Okay. And I'd say, all right, well, I took care of getting rid of my denominator by multiplying it away. Great. I love that strategy. It makes these problems easier. So what's left? Well, R is being multiplied by 870. So let's do the opposite. Let's divide by 870. Okay. So that leaves us to the nearest whole number, 7244 RPMs, revolutions per minute. And that would be how to do it. Okay. In two steps. I could have done it in one, but it didn't really matter. Okay, last one. Unfortunately, we don't have a lot of these like this. In fact, I think this is the only one. This assignment. There might be another one. Number 15. Now we got an exponent hitting the variable. How do we handle that? Well, first we plug in the numbers, or not. Okay. So find the weight of the car. Okay, so we're solving for W. Okay, that's not going to be too bad. With 480 horsepower, so our H is replaced with 480, and a speed of 132 miles per hour. Oh yeah, that's how you get to work. Okay. I mean, you need a car that goes that fast, so you can say, to your wife, husband, whatever, goodbye, dear, and then you're at work just that fast. All right, and so we've got this. So what do we do? Well, if you look closely, you'll notice that W is being multiplied by that, okay, and that is really just a single number. We can plug that whole thing in, okay, and so let's do it. I'm going to pause for just a moment. Okay, and so that's going to be about 0.1795 for all of that, including that exponent of 3. So now I just say, well, let's just divide by 0.1795 so that those little guys cancel. And what do we get here? Let's see, it says to the nearest pound, 2674. And as always, I remember my units. Okay, 2674 pounds. And all right, that's how it's done. Not too bad.